So welcome back again to my channel, and at the previous video we had provisioned the Kubernetes clusters with K3s from Rancher Labs, but only one for single node in master, and it only comprises of the etcd master and control plane in one single node. But here in today's video I'd like to introduce you about the high availability clusters and comprise of the three master node, at least three, and the worker node is also synchronized with the node number of master nodes. But the worker is actually, the requirement here is only one, so we don't need to worry about the worker node. At least it has one, and master node at least it has two, so we can move forward with that manner. So first of all, we'll be going to have a Rancher UI first. If or you haven't installed the Rancher UI yet within your infrastructure, please go visit or try to revisit the Rancher documentation. You can actually try to install within this documentation. Is already have comprehensive documentation to deploy your Rancher UI. Here I'm using the Helm CLI quick start, and you can start following this documentation and you're ready to go. Secondly, we will try to provision the master node by using the Terraform, but if you don't have a Terraform, you can actually use the manual and AWS console management from this and launch instance. It's okay, so don't need to worry about that. The output should be the same. And the last one, we will be going to provision the worker nodes, but here is the important of the worker nodes. We will leverage the ASG or Autoscaling group from AWS in order to make the auto-scaling the worker node. For example, we only at the first time provision one worker node, so worker number is only one, and once we leverage the auto scaling, it will be add worker node once there are lots of pods in pending state already within our clusters, and it will be pending and it will be rescheduled to the new worker node, and worker node will be provisioned by the Autoscaling group. But before that, something that we need to install alongside the Autoscaling group, this is the external module that we need to install, the Autoscaler, cluster Autoscaler. So it's basically from the Kubernetes, and we need to install this later on in this hands-on video. Nice. So let's go back. So if you try to look to AWS console of my Rancher is already there. I provisioned it already a moment ago, so please visit your Rancher UI. In this use case, I have the public IP, but I tried to provision by using the SSL, so I already integrate my DNS name, my custom DNS name to the Rancher. I can try to visit my Rancher UI to this one. This is my Rancher UI page. It only has the cluster local. Currently this is my cluster local. It don't have any additional clusters here. So in order to make the clusters, new cluster, it's pretty simple, and we'll be going to first to create a master and worker node, right? So just try to navigate here to cluster management, and there's the create button in the top right corner of here. After that, it would be nice. There's a lot of cloud providers over here. We don't need to worry about this button, and everything is button here. Just try to focus on here in this button, this switch button. We make sure that EC2 and K3s is selected, like we switch to the right one, not the left one in RQ1, no. So the right one is the best. We will try to provision the K3s later, and here we need to click this custom instead of all of this, because even though we will be going to use Amazon EC2 instance, but we're not going to use this feature, but we'll use the custom feature instead. Here, click on it and just try to fill up your cluster name, the field here. I want to try to fill with the clusters K3s. Here is my cluster name, and under the basics, listen, under the basics that you have the Kubernetes version here. There's a lot of version, RKE2 and 128, 127. please don't select all of this under the RKE2. Instead, you will be going to use the K3s, because I had tried to provision by using RK. It doesn't work several times. Kubernetes cluster with K3s working correctly like a charm. So after that, we don't need to do anything. Let all of them by default as is. We don't need to modify anything. So let it the self-explanatory etcd registry advanced, make it default, and just try to make sure there's create on the bottom right corner, and click the create button. Nice. Now our cluster is getting ready, but here we have lots of tabs, and we first appeared in the registration tabs, and we are now here in the step 1. There's 2 steps, main steps here. The steps 1, we need to select the role of our workload later. So I will try to select etcd and control plane only, not worker, because in this design the master node only comprises of control plane and etcd only, without worker. So we'll try to separate between the master and worker. So that's why I try to select etcd and control plane first, and the second step I try to select or try to check the radio button here, and select and copy this command to the Terraform of the master node. So this is my Terraform for master node. Try to select and try to replace the user data, but you can actually use the SSH and try to perform this command within your instance, but I want to instead to use user data to make it simple, so I don't need to do anything at all. Once the instance is ready, it will automatically run or performs your command. So here it's already done, and for the worker we try and select the worker only, and copy this to the worker node instance variable. Nice. And other thing that we need to do is make sure that in related resources we look up for the cluster ID. This is the management cluster is cluster ID, CMFSD blah blah blah. So you name it, this is the cluster ID. So you need to create the, for worker node, we need to create the tags. So the tags for the cluster autoscaler is having 3 tags here. The first one is Autoscaler enable true, and the second one is clusters and cluster ID. Change and replace this cluster ID here, and the last one is cluster Autoscaler with your cluster name here. So it will match your cluster name here. You need to change this or replace this as well. Nice. And other than that master node, we only have 1 tags. We only need to change this here, replace. It doesn't have the cluster autoscaler because we don't want to try to scale the master node, right? Only want to scale the worker nodes. Damn, that's good. So after that, just try to push this commit new worker and master. Try to push this, and before that I would like to let you know that I'm using the Terraform AWS module for autoscaling. This is actually the autoscaling Terraform modules. You can actually refer to the register the registry, the terraform.io, so you can refer to this page for doing the autoscaling templating your Terraform. So I'm using this as a single source of truth, and I'm using the version of 7.6.0. Seems pretty normal for the variable. I'm using the spot instance. I'm using the Ubuntu 22.0 and instance type like this. Also the instance profile. So make sure the instance profile for you you can refer on in this Kubernetes Rancher documentations. So here we already have the documentation in order to get or attach the policies and what policies that we need to attach in the role And then here in the first policies, and this is the second policies, and most likely there are auto-scaling policies and EC2 policies with the elastic load balancing policies as well. And that's it. That's a simple thing. And after that, we need to make sure that we provision it very well. I'm using the automation. So I'm using the automation. I'm using the Terragrunt. So let's apply this Terragrunt within our infrastructure as code. But you can actually use the same thing manually by using the launch instances. But I don't want to use that because the simplicity and to save the cost of time. So our Terraform plan is already come up and everything is ready. One add, one changes. So basically we try to create two resources. The first resource is launch templates and the second one is autoscaling groups. So launch templates is our templates for the autoscaling groups, and it attached to the autoscaling groups. Autoscaling groups will try to provision based on the launch templates. So try to apply this. So we can try to look up later in the AWS console management system once this already merged. Nice. So we'll be going to create the autoscaling group, right? So let's refresh this. Now we have master and worker. Each of those have one instance count. So now we have the worker and master autoscaling group, and each of the autoscaling group has one instance count, and it is on the launch templates that is already created alongside the autoscaling group as well. So if we try to see the instance, so we will see the master and worker already provisioned already within our instance. If we go back to the Rancher UI and click on the machine tabs, it will be attached to these tabs. So it will come up. Look at that. So we already have the control plane and etcd that is already come up in this machines tab. Try to wait for the workers as well. The workers are also working. So we need to wait for the reconciliation between them. So they will reconciliation each other and try to synchronizing, communicating each other to become clusters. So here we, in the meantime, we can see the provisioning logs. Here the control plane is waiting for the agent to connect, which means that it will try to connect to the nodes of the worker. But here in this first step, we only have one control plane. We as our design has three, we will try to increase the master node later after this. But you can actually use the three instance at the first time, but I forgot. So let's try to increase the master node here. In the meantime, we can see that again, it is still try to connect to the agent. Yeah, let's try to apply again our master node to become 3. We'll satisfy the high availability manner for this use case in this video. So we can try to apply the changes for the 3 master nodes. And here in the first master node is already running, and it will reconciliation with the worker node, and worker node will also be ready and up and running as well. See, it's up and running, and we need to wait our 3 master node to become ready again. Let's try to wait again. It's probably fast forward 1 or 2 minutes. So as can be seen that the age is only less than 3 minutes. We can try to provision our clusters, and it doesn't take longer time in order to try to provision your Kubernetes self-hosted in K3s. So as we can see here, there's 2 master nodes already running here, initializing. So just need to wait for that to become ready to join our clusters here. So both of the instances already joined the clusters, and it's still waiting for the initialization plan and many things to join the cluster fully, to join the first master node. So for this, the first additional master node, it doesn't take longer time. It only less than 1 minute to join the clusters. We can see the difference between, if we compare to the previous one, the old one, the first one, it has 3 or less than 3 minutes, but this time we only have 1 minute or less. So the cluster is already up and running. Let's try to obtain the kube config from here, and let's see. I'm going to remove my previous kube config, create a new ones. So try to kubectl get nodes. So we can see that control plane, we have 3 control planes and the 1 worker. Now we will achieve the second use case, that is the autoscaling group for the work nodes. And using the autoscaler, the clusters autoscaler is the essential part of this use case too. So once everything is ready, we need to prepare for the cluster autoscaler. So you can actually follow this Rancher documentation, but I will not try to focus on documentation because all of this is pretty much take longer time to understand. So that's why here I will try to explain more in easy and friendly way. Hopefully, you first need to create the this manifest file, and the manifest file is actually you can obtain it from the Rancher documentation. So you can select this Rancher manifest file to your local, and you try to modify a little bit more variables. So here I will try to show you the variable that we need to edit. The first variable is here in the comment of the deployment. So let's try to visit in the 1-to-1 line. This is a kind of deployment, and kind of deployment has container, the container has comment, and within the comment, in the last comment line here, we have this last postfix of this comment. We have the cluster K3s. It will be matched to the cluster name here, the cluster K3s. So it already matched, so we don't need modify that again. And we also need to select the version of the cluster autoscaler. We can try to see the list of cluster autoscaler to see it or access it to the GCR. Yeah, we can access the GCR and see which one is the available version for this autoscaler. But I'm using the latest version 126.2, so it's gonna be our version today. After that, make sure that in storage kubernetes.io you try to add the CSI storage capacities and CSI drivers as well. And after that, in the API groups of null, the resources alongside the pod services, replication controller, persistent volume claims, and PV, we need to add the namespaces as well. So make sure that everything is also right here. Apply this manifest. Yep, that is already good. And make sure that you have this tag. You have this tag in your worker nodes. You also have this tag in your worker node. If you remember that the first time you made the tags already, right, in our worker nodes, here we try to see this worker nodes, we have tags here. This is the tags of our clusters, and this is the tags of the cluster name. So it will match between those things. Cluster autoscaler is enabled. Cluster autoscaler is actually enabled. It's supposed to be enabled here. Cluster autoscaler enable is true. So yeah, so let's see our workload for the cluster autoscaler pods is already running or not. Here the cluster autoscaler is already running, so we can see the logs. There is a sign that there is no candidates to scale down, which is good, pretty good, because we don't have something to scale down, and we need to try to simulate the deployment. And so we expect to cluster autoscaler to run to scale out our worker node. We need to scale out the worker node to become 2 or 3 with this cluster node, cluster autoscaler. Apply this manifest, go to the Rancher, explore here, import the YAML file, and import this. So if we back here, the container creating is only have 2 pods, but one of those things is pending. So let's see the autoscaler. See in this log, so we have the unschedulable pods since there is a scale up attempt in this loop. So meaning the autoscaler already detects the pods that is already pending in pending state for a long time. So that's why he needs to communicate with the autoscaling group to increase or add one more nodes. So if we see in the instance console, the autoscaling group here the worker is already 2, desired capacity is increased to become 2. So if we see the activity, so the capacity is added from 1 to 2, meaning it's coming from this cluster autoscaler actually. Yeah, we need to wait it until it's getting ready to join the clusters too. So we need to wait 2 worker already up and running. So let's see, it's there. I mean, the nodes is already here. So the age is 30 seconds, 40 seconds, and the pod is already scheduled to the node. For example, we have this brand new worker node. The IP is 30.0.1.2.102.21. So the 21 node So if we try to see here in this pod is scheduled to this node, so actually it's already working perfectly. We made the cluster autoscaler working with using the autoscaling groups for our clusters. We can make the more hello world to become maybe 5 replicas, so we can increase this 5 to become 5 replicas. See, 5 replicas, and there's a one pod pending, and let's see the logs here. It also wants to scale up based on the available replica that is still pending state. Basically, the autoscaler is already working, and we made our goal today. So we made it. Yeah. So let's see the autoscaling groups. It becoming 3 instance for the worker nodes. So the instance here is already up and running. Probably this is still initializing, and let's see, the worker nodes should be 3. It's only just 2 here, so we need to wait a little bit more, maybe 20 seconds. Still pending. Here there is the last worker nodes that is provisioned and join the clusters. Here the age is still 10 seconds. Let's wait until it getting ready. It's up and running. Let's see this container creating, and yeah, it works. It really works. And the master node, the worker nodes, new worker nodes is 103 and 10. Let's check up here. The worker node 20 seconds is 103 and 10, so it works. How about the scale down? If we want to scale down, we need to wait 10 minutes. For example, we want to change back or modify back this replica to 0, which means that every parts of the hello world will be terminated, and once the nodes is underutilized and the cluster autoscaler detect that the nodes is underutilized, it will try to scale down in 10 minutes. We can actually tune our duration of the scale down, but here in this documentation that there is a here the scale down unneeded time is 10 minutes. So how long a node should be unneeded before it's eligible to scale down? It's basically have the default value of 10 minutes. You can try to modify this in your deployment of the cluster autoscaler from here. So you can add this one more. For example, it's called scale down here. You can try to modify this and apply that again. So that's how the autoscaler works, and I thank you for joining us today in today's video. And probably the last thing that I want to share to you guys, that it works because I am using the provider ID of AWS. So the provider ID AWS, I try to make this working by using the user data. So I generate the provider ID by using user data, and the availability zone and instance ID I fetch is by using the metadata of the AWS EC2 instance, and this provider ID will be generated to become the kubelet configuration. After the kubelet configuration is ready, I put the kubelet configuration to home Ubuntu, this one, and then the K3s configuration option is already automatically detect config YAML file here. That's why I try to define the kubelet arguments, the config, and it will refers to my configuration of kubelet configuration here from the home Ubuntu config, and this path, it should be deployed to this YAML file. It is a Rancher K3s config.yaml, and it will automatically detect it by the K3s to add one kubelet arguments in a node arguments in your node of your K3s. For example, I want to try to look up this control plane. We can see that there is, wait a minute, here we have the K3s.io node arguments. We have the kubelet args, which is refers to the home Ubuntu config.yaml, which is this YAML file consists of our configuration of the provider ID. So that's why the Rancher machines provider ID become the AWS. Previously, if don't set this mechanism, the provider ID will refers to the K3s colon / blah 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 instead of AWS cloud provider. So the cluster autoscaler will not working. So that's why in order to make it working, we need to modify the provider ID to AWS format instead of the K3s format. So that's the tricks. Thank you so much for having me in this video, and let's meet in next video.